Multilayer PCBs impact on the PCB assembly process. Multilayer PCBs can have a significant impact on the PCB assembly process compared to single-layer or double-layer PCBs. Here are some ways in which multilayer PCBs affect the assembly process. 1. Complexity. Multilayer PCBs are inherently more complex than single-layer or double-layer boards due to their multiple layers of conductive traces and insulating layers. This complexity can make the assembly process more challenging and time-consuming. 2. Additional layers. Multilayer PCBs consist of multiple layers of conductive traces separated by insulating layers. Each additional layer increases the complexity of the board and the number of interconnections that need to be made during assembly. 3. Through-hole plating. Multilayer PCBs often require through-hole plating, PTH, to connect traces between different layers. This involves drilling holes through the PCB and plating them with conductive material to ensure electrical connectivity. PTH adds an extra step to the assembly process and requires precise drilling and plating techniques. 4. Component placement. Component placement on multilayer PCBs can be more challenging, especially when there are multiple layers with components on both sides of the board. Care must be taken to ensure that components are correctly aligned and soldered in the right locations. 5. Soldering challenges. Soldering on multilayer PCBs can be more complex, as heat from soldering can affect adjacent layers. Specialized techniques and equipment, such as reflow ovens with precise temperature control, may be required to prevent damage to the board or components. 6. Signal integrity. Multilayer PCBs are often used for high-speed and high-frequency applications where signal integrity is critical. Proper design and assembly techniques are essential to maintain signal integrity and minimize signal loss or interference. 7. Testing. Testing multilayer PCBs can be more involved. In-circuit testing, for example, may require specialized fixtures to access components on different layers. Comprehensive testing is essential to ensure that all connections are functioning as intended. 8. Rework and repair. In the event of a defect or component failure, rework or repair of multilayer PCBs can be more challenging than with simpler boards. Accessing and repairing components or traces buried within the layers may require advanced techniques and tools. 9. Cost. Multilayer PCBs are generally more expensive to manufacture and assemble compared to single-layer or double-layer boards due to the additional materials, processes, and complexity involved. 10. Expertise. Working with multilayer PCBs requires a higher level of expertise in both design and assembly. Designers must consider layer stack-up, signal routing, and thermal management, while assemblers need specialized skills to handle the complexity of these boards. Despite the challenges, multilayer PCBs offer several advantages, including reduced size, improved signal integrity, and increased component density. These benefits often make them the preferred choice for advanced electronic devices and systems. Successful assembly of multilayer PCBs requires careful planning, attention to detail, and adherence to best practices in PCB design and assembly. Thanks for watching. For more information, contact us. www.anzerusa.com